Hello, today we're going to look at the rotting oranges problem, which is a very common question in Amazon for BFS. So let's see. In a given grid, each cell can have one of three values. The value 0 representing an empty cell, the value 1 representing a fresh orange, value 2 representing a rotten orange. Every minute, any fresh orange that is adjacent to rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1 instead. So there could be many ways to do this, but basically every method would use BFS. The implementations can be different by person. However, the method I will use would be first count how many oranges are there. Orange num equals 0, and how many rotten oranges are there? So, and after this, I will just do if the grid ij equal 1, then okay, we'll just do fresh num equals 0, fresh num plus equals 1, orange num plus equals 1, and I'll if grid ij equals 2, then orange num. Actually, we don't have to do fresh num, we can just subtract from orange num from fresh num. Okay, let's just do it. Fresh num and rotten num plus equals 1. So after this, we're going to have all the rotten oranges and all the orange numbers, and also we're gonna use BFS, so we're gonna make a queue, which can be called from collections.deck, and we're gonna put the tuples of the rotten oranges inside it, which would be q.append left and I, j. And after this, we're going to basically do BFS, which would be while q, and we're going to have the q num, so this would be the length of the queue, and we're going to use this to pop for in range of q num we are going to pop from the queue, queue.pop, and we're going to see like the left, right, middle, down and up. Yeah. And to do that, we can just make directions, which would be an array of tuples 1, 0, 0, 1, minus 1, 0, 0, minus 1. And after having this node, we're going to basically do a for loop for directions and set new x, which would be direction 0 plus node 0, new y equals direction 0 plus node 1, and we would have to check if these new x and new y are inside, and it is like the fresh orange, which would be if new x is inside 0, and it should be, is it the square cell? It's just like a rectangle cell, so we would have to do new x smaller than good 0. And after this, we're going to do new check if this is the fresh orange. If grid new x new y is fresh orange, then we will make it we will basically make it to rotten, and actually, if we do this way, we don't even have to have like fresh num and orange num, but we need to do q.append lift, so let's just deal with it. We will use the count equals 0, and we will do count plus equals 1. So every time we do a BFS, like one step from the BFS, we're gonna increase the count, and we're also going to put it inside new x new y, and we'll not do anything if it's 0 or 2. After doing this, we're just going to simply return count. Let's see if this works. We have a typo. We have another typo, really? Invalid syntax, really? Oh, what is this? And output is 5 instead of 4. So let's actually see what's happening. When we do this, it would be 1. When we do this, it would be 2. When we do this, it would be 3. When we do this would be 4. So why is it becoming? I think it's because we are adding count and then like popping out and infecting the the oranges. So let's see if this would definitely work. And how about this? It's the wrong answer. Oh, I'm really sorry. We should. This is right actually. Output is 4. Expected is -1. Oh, I see. Okay. And we actually need the orange num and rotten num and fresh num. And we will see if orange num is equal to rotten num, then return count -1, unless return -1. And let's see if this works. And it works. So actually, I'm actually curious why this is count -1. So let's simulate this. So let's say we have 2 1 1 1 1 1 1 1 1, and at this point, this would be count equals 1, right? And after this, it makes it to this. Oh, I see what's happening. And after being this, it makes the count to 2, and after that, we're going to update this to 2 and 2. After this, we're going to 3, and we're having 4. And after this, we are doing 4, and we are updating this the 2. Why is this 5? Let's actually see what's happening here. We need a print statement. So it is going in, even though so inside the queue there's only one. So there's only 0, 0, and after that there's 0, 1. Why isn't 1, 0 inside? That's a good question. Why isn't 1, 0 inside? This will definitely gonna be a problem. 1, 0, 0, 1, minus 1, 0, 0, minus 1. Zero, 0. Oh, if 1 10 left. Yeah, there should be 1, 0 inside, but there isn't. So we actually have a problem here. So it won't work. Yeah. It's expected. Okay, 0, 0 is inside. Let's actually print out more. Zero, 0, 1, 0, 0, 1. Why isn't 1, 0 inside? Maybe it's not inside here. It is inside here. So how about is it not inside here? It is not inside here. So it means new x, new y. 2, 1, 1. Oh, it's different from this. Okay, that's why. Oh, okay. 0, 1, 1, 0. 0, 2, 1, 1. Oh, where is rotten now? So it turns out that our code was not the problem. It was just the test case was different than what we were expecting. It's kind of long code, but I think count is the right one, basically. No? Okay. And okay, let's see. 1, and there's deck Q of 0, 0, and five. Okay. Okay. Now I get why we have to do -1. It's because even though we made this rotten, we put it inside the queue. So it'll go through everything. Even though there are no other rotten oranges left to rot. But that's the reason we have to do -1. And it works. Let's comment out everything. Test one more, and then 0. Expected is 0. Okay. So that means if there is no rotten, what is the no cell has a fresh orange. No cell has a fresh orange. Okay. That actually means orange num minus rotten num equal 0. Then return count. That wouldn't even do. So that's like an edge case actually. So we'll just handle it here. If orange num equal 0, that means there are no fresh oranges either. So return 0. Okay. That makes sense to me. Okay. And it's faster than 96.25% of Python's free online submissions. So that was Rotten Orange. That was kind of tough. And if you don't know how to, if you're not familiar with these kind of questions, it could be quite tough. And let's see you another time. Bye.